Okay, so we're starting exponentials and logarithmic functions. All right, this is going on page 85. I want you to open your ISNs to, I think, page 56. See what's on page 56, and I'll tell you if that's what I want. Oh, look at that. You're just like a pro over here. All right, so on page 56, and you may need to access the stuff before it as well. We're going to start by looking at these parent functions, which was a review back when we did it early on, and then it's a review again. So I want you to start off by just going ahead and sketching these two. I'm going to give you a second to do that. You can look at your ISN. You can talk with your neighbor about it. Make sure you agree on how to sketch these two exponential functions. That's why I said you can use your notes. If it's a sketch, it should be going a whole lot faster than this. The first one, at least. The second one, I'm not so sure how much you really did that in Algebra 2. And I didn't get a chance to go check on that with Ms. McCorder. But all right. So, Katie, tell me, what's the domain of this first one? All real numbers? Okay, good. You gotta talk louder than I'm moving. All right, what about the range? Thank you, Z, Katie. The 0 to infinity? Okay. All right, and then Zeke, what's the asymptote, or do we have one? What is it? Y'all can answer in stereo if you would like. Y equals 0. Okay, do we all agree with that? Yes. Okay, so one thing that, because we're going to talk about sketching and graphing and the difference between the two, or at least how I'm going to define the difference between the two, is that the asymptote needs to be graphed regardless of whether or not you're sketching or graphing, right? So our asymptote is here. Now, for the parent function, if there's no translation left, right, up, or down, then for an exponential, there's one key point that'll be the same every single time. Who wants to tell me what that is? What is it? 0, 1. Okay, so I know that this is happening. Since it's a parent function, it's here at 0, 1. Right? And then if you can get the asymptote and that 1-point graph and you know the general shape, that's good enough for a sketch. Okay, because the sketch is just getting the idea of what it looks like. If you need a couple of points like in your head to do that, whatever, but you should know at this point, because it's been reviewed a few times, that once you get your asymptote in that 1 point, that you can just get the general shape of the graph that looks like that. Okay, so that when we do the translations, that you can just quickly like think about what that looks like and then what you're going to do with that. Does that make sense? Yes? No? Maybe? Yes? Okay. All right, so then let's look at this next one. Who wants to tell me what the domain is over here? Somebody that hasn't. Christy, can you tell me? What's the domain of this one? All real numbers? What's the range? Zero to infinity? And what about the asymptote? Y equals 0? Were those all three a guess? I thought so. You can tell by the Is she right, though? Yes. Okay. So regardless of whether or not the b here is greater than 1 or between 0 and 1, the domain, range, and asymptote remain the same for the parent function. Does that important point remain the same also? Yes, because when x is 0, what's anything to the 0 power? 1. So that's here. So the only difference between these two is that they're really just a reflection in the y-axis. It looks like this, and this is good enough for a sketch. Okay, everybody okay with that? Those we should be able to sketch quickly. Okay. Whew. All right, so recall that, and this is recall, right? Recall means we already know this. Exponential and log functions are what of each other? Fuang. Exponential and log functions are what of each other? How are they related to each other? What's the magic word that goes in there? Nico can help you if you want. Are they related to each other at all? Huh? Yes, how are they related? We'll pass out. Inverse, good, very good. Inverse. Recall that the exponential and log functions are inverses of each other. Therefore, we can always rewrite a log as an exponential if we need to make it make more sense for us. But either way, when you graph inverses of anything, what do you do with the x and y values? Switch them. Switch the x and y. Switch or exchange or replace or substitute. Okay. So let's look at these down here. So knowing that, not only that, but if anything, if a graph is an inverse of another one, it is also a reflection in what? Raise your hand if you can tell me. Bonus points. It'll make you my favorite geometry student. An inverse of a graph is a reflection in what? Think about it. Picture the inverse of something that's not this. What? Not the y-axis. What? Y equals x. Yeah. I saw you doing this, like the hand jive or something, but okay, y equals x. So if you know that, because remember when we reflected things, and you know when there are triangles and stuff like that, when we reflected the y equals x, that means that all the ordered pairs, x equals y and y equals x, you just switch them around, right? So visually, that you need that to help you with this. If you know these are inverses of each other, it can help you figure out what the graph is supposed to look like when all you really care about is the shape. Well, that's not all you really care about, but so let's do this one here. Let's think about this. The sketch, if we're going to sketch this, this is the inverse of 2 to the y equals 2 to the x, right? Because if I was to rewrite this, this would be 2 to the y equals x, yes? And I could just substitute x for y and y for x. So when I get that, that means that this is just the reflection in the line y equals x of that first graph that you have up there. So does that change my domain? What do you think? Would it change my range? Would it change my asymptote? Because everything reflects. If I have this, and I'm going to reflect this in the line y equals x, that's this line right here, right? That means all of this reflects over here. So does the asymptote change? You all graph logs before? Okay, oh, good. The answer is yes. You lie to me, I'm going to go down the hall and I'll find this in the quarter. Okay, so what is the asymptote for a log function? You have your notes in front of you. You need it. The parent function, not just any log function, but the parent function. If I take the, what was it up there? The line y equals 0. If I'm going to take the line y equals 0 and I'm going to reflect that, it'll be x equals 0, right? Because it's here, it gets reflected, and it becomes this one. So now my asymptote is x equals 0. So that in that important point that we had, which was at 0, 1, where does that go? 1, 0. So I ask you again, does your domain change? Yeah, it does. When you do the log, if it's a parent function and you haven't transformed it at all, are any of your x's going to be 0? 0. Well, obviously not, but are they going to be negative? Can you plug in a negative x right here? No, right? So what is my domain going to look like? 0 to infinity. Good. What about my range? All real numbers. So not only does my graph get reflected in the line y equals x, my asymptote goes from y equals 0 to x equals 0. What happened to my domain and range? They switch places too, right? Because aren't those your x's and your y's anyway? So if you can relate all that together, it should help you make a whole lot more sense. So now I just have to decide here if it's going to come from here down or from down here up. So am I going to start at positive infinity or negative infinity if I think about what the reflection is there? Or if you just know what the log looks like. Do I start at positive or negative? Negative. Comes down here. Looks like that. Everybody okay with that? Now if I change the base of the log, is that going to change my asymptote? No. So it's still x equals 0. Does that change my domain or range? No. Okay, so this is 0 to infinity in all real numbers. So I'm going to go ahead and draw this. Does that change my one key point that I have here? No. And again, if you know the exponential and it's just going to reflect, just like the two exponentials were different than each other, this one here, I'm starting at positive infinity. If you know what these basic parent functions look like and you can graph them quickly, you can get through all the transformations you need quickly. Okay, whether you're asked to sketch them or graph them, and I will explain to you what the difference between the two is. Questions? All right. Turn the page. Or flip it over or whatever. There's a quick little review of transformations. So I'm going to give you a couple of minutes, and I want you to go through, well, we'll do the first one together so you understand what I mean, but and just explain the effect on the graph. So let's look at this one, y equals 2 times 2 to the x. First of all, do I get to multiply the 2 times the 2 and get 4 to the x? No, I do not. Okay. Which means that my parent would be y equals 2 to the x. So multiplying that by 2, is that a change on the x or the y? The y. So if something is happening with y, is that horizontal or vertical? Vertical. Okay, so this is a vertical something, right? So this is a vertical what? Stretch by factor of 2. Make sense? So just a quick little explanation of what that is. All right, so I'll give you a couple of minutes to do the rest of those. All right, let's go ahead and start going through these. All right, so look at one. Hannah, is this something that's happening vertically or horizontally? Horizontally. So I know since it's happening to x, it's horizontal, and it's a horizontal what? Shift left. How many? 3. Okay, good. Thank you. Y'all agree with that? Yes. All righty. So then the next one. All right, Annis. So is this horizontal or vertical? Okay, and it's a vertical what? Okay, good. Well, okay with that? It's just like all the rest of them, all the rest of the parent functions. All right, George, is this horizontal or vertical or both? Okay, vertical. So what do we have here? Okay, vertical shift down 5, and what else? Reflection across the x-axis. Good. Which one will we have to do first? The reflection. Good. So I'm going to write it first. Reflection across x-axis and vertical shift down 5. Okay, very good. Thank you. All right. Next. Christy, what is this? Okay. Which way? Okay, good. Thank you. Horizontal shift right 1. Then this next one. All right. Jasmine, what's this one? Okay. Vertical shift what? Good. Down 1. Yes? Okay, good. All right. Another question. I'm just assuming I got yours. Katie, what's this? Okay. Reflection across x-axis. Shall I agree with that? Yes. And then this one, and then I'm going to add one. I forgot to do it. I decided to put on there and I forgot to do it. All right. Maria. Okay, good. Verticals. Okay. Yes, vertical stretch. There you go. Vertical stretch by factor of 2. All right, and then I wanted to add one. We're going to add this one. Y equals log base 2 of 2x. Log base 2 of 2x. What is this? It's a what? Horizontal compression. You agree with that? Remember, whatever's happened to x, you do the opposite there. Good. So it's a horizontal compression. By factor of 2. All that should be old business. Just a quick reminder of what's happening with those. Okay. So let's look at the next couple. We're going to sketch and graph, and we're going to look at the difference between what that really means. All right, so this first one says to sketch this. So before you ever do it, you want to make sure that you have in your mind what the parent function looks like, right? This is an exponential. So for our exponentials, our important point is right there, right? And the part that is being taken to the exponent here is a fraction. So do I start at the y-axis or do I end, I'm sorry, at the x-axis. Do I start at the x-axis or do I end at the x-axis? End. So it's going to look something like that, right? So if you know the general shape and you know where your important point is, then you can think about what's happening here. Here is where you would normally start, right? I would normally start here. But I am being reflected in the what? In the x-axis. So it's actually coming down here. And then in addition to that, that is actually a vertical stretch. So instead of being 1 away from the x-axis, I'm how many away? 2. So my point is actually right there. And so if I looked like this to begin with, and then I got reflected in the x-axis, it's going to look like this. But then I have to decide, did my asymptote move? When's the only time the asymptotes move? Okay, well, yeah, they move when you take the inverse, but don't they also move when you shift? Like if I'd have shifted up and down, would my asymptote have moved? Yes, but I didn't actually shift, right? I mean, I moved this point, but that's because it got stretched. So since it looked like this, now it gets reflected, it's just going to look like this. Oh, but better. We say but better. Something like that. It's going to get stretched that way. So that is, in general, what it looks like. That is your sketch. For your sketch, you only really need 1 point. And you just think about what happens with your transformations and go from there. So with this, your domain is still what? All real numbers. The range changed, though. I'm going from negative infinity to 0. Did the asymptote change? No, it is just y equals 0. But the asymptote needs to be drawn in there. We'll put something like that. Okay. When we go to graph it, when you graph it, that means we want 3 points. And it's a little bit more exact. Okay. So I would start with a little t-chart here of my parent function, my original x and y. If this was just y equals 3 to the x, okay? So if I just had y equals 3 to the x, just the parent function, then I would choose negative 1, 0, and 1 is my 3 points, because those are easy, right? What is 3 to the negative 1 power? What is 3 to the negative 1 power? 1/3, okay. Silence scared me there for a second. What's 3 to the 0 power? 1. What is 3 to the first power? 3. Now that is my parent function. That is not this, right? That is not what this is right here. So instead of trying to make a t-chart for this, and instead of just getting the shape, I can take this, and I'm going to extend it to get the actual new x and y that I'm going to use. So when you look at what's happening here, what happened to your x values? Or what happens on as far as x is concerned? Left 2, right? So for each of my x values, I can just subtract 2. So negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. As far as the y value is concerned, I'm shifting down 5, right? So I'm subtracting 5 from all the y values. So 1/3 minus 5 is negative 4 2/3. Would you agree with that? And then 1 minus 5 is negative 4. 3 minus 5 is negative 2. See, the problem with just finding a t-chart and to fill in these numbers is that if I pick negative 1, 0, and 1, to plug into this, my numbers might be all weird and difficult to use. Does that make sense? So unless you kind of know and you can predict what to do with this, then this is a good way to do it. You can do it a different way as long as you have good points to use. So this part right here, this was my parent function. I'm not actually using that. I used that to get my new points. Now I also want to have a good idea of what's happening just in general from my parent function. My parent function looks like this, right? So with that, I know I'm supposed to shift it over and I'm supposed to shift it down. So I still know what the basic shape is supposed to be. Is that going to change my domain? No, my domain is going to stay the same, right? Is it going to change my range? Yeah, okay, we can think about what that is in a minute. Is that going to change my asymptote? Yeah, because my asymptote was at y equals 0. Now where is it? Y equals negative 5 because it shifts down. So I'm going to go ahead and draw in my asymptote right here. Right, so y equals negative 5. And then I've got 3 points that I can plot here. I'm going to go to negative 3, negative 4 2/3. So 1, 2, 3, 1, 2, 3, 4 2/3. That's pretty darn close to there. Then negative 2, negative 4. And at negative 1, negative 2. All right. Everybody good with all that? And then you know what your shape is supposed to be, so it's going to come up here. Oh, I can't ever hit those points. Something like that. So, what is your range? What's the lowest it can be? Negative 5. Do I get to include it? No. And then infinity. Everybody okay with that? Any questions? All right. So let's take a look at this one. This says to sketch. So I want an idea in my mind of what the parent function looks like, right? If this is a log and the base is greater than 1, then it's going to look something like this, right? So if my point is right here, right, that's where I would be for my parent function. This point does it get shifted left or right any? Yes, it goes which way? To the right. How many? 1. And then what happens to it? Up 2. Okay, so there's my point. Because I shifted, sometimes when I shift, it changes my asymptote. Sometimes it doesn't. Did this change my asymptote? Yes. What is the asymptote originally? X equals 0. This is where the asymptote is, right? So if there's a vertical shift, it doesn't change anything. If there's a horizontal shift, it does, and I shifted to the right one, which meant I went from x equals 0 to x equals 1. So my asymptote is x equals 1. And then the rest stays the same, and it looks something like this, which means my domain, is it restricted? What does my domain start at? 1 to infinity. Is my range restricted? No, it's all real numbers. So there's my sketch. Then I'm going to have my graph, right? So same parent function here because the base is still greater than 1, so it still looks something like this, right? Well, actually not that exciting up there. And then, so if I can start with, now here, you've got a couple of options here. What I would suggest maybe you do is to go ahead and change it to an exponential. So if I wanted to do that and I wanted to be able to take 3 to the y power, then I have to take care of this first and I have to divide this over there to get negative 1/3 y. Everybody understand why I'm doing that? Equals log base 3 of x, because otherwise I can't change it to an exponential. You with me on that? We know how to change exponentials to logs and vice versa? Okay. So then this is going to give me 3 to the negative 1/3 y power equals x. Oh, so when you are trying to find these, I would suggest that you pick points for y instead of x. And on top of that, do you want to plug in numbers to this? Like, is that going to be pretty? What if I do negative 1 and I plug that in here? That's going to be a negative 3 to the negative 1/3 powers. That means I'm taking the cube root. Do we want to do that? No. That's why this is really going to help you if you actually just do it from the parent function. And my parent function would be y equals log base 3 of x, which means I'm just looking at 3 to the y equals x. And that becomes a whole lot better. You see the difference? If we do that, then do the transformations, things come out a lot nicer. So if I plug in a negative 1 here, what's 3 to the negative 1 power? 1/3, right? What's 3 to the 0 power? 1. What's 3 to the first power? 3. Okay? So this is my parent function chart. Then does anything happen to the x values? Do they change at all? Anything horizontally happening here? No. So I really am just changing y. So y, there is a vertical stretch and a reflection, but aren't all the y values just getting multiplied by a negative 3? So if I just take that negative 1 and make it a negative, that would make it a positive 3, right? 0 and negative 3, because I'm just multiplying each of the y values. My x values stayed the same. These are my y values for my parent function. I don't need them anymore. But they helped me get that a whole lot quicker than using this thing right here and trying to make sure that I actually change it correctly. And then on top of that, choosing nice y values. Does that make sense to you? So you can just decide how to, whatever makes sense to you. Now, since I'm not shifting anywhere, does my asymptote move? No. So what's my asymptote? X equals 0. Okay. So my asymptote doesn't change, so let's go ahead and put that one in there. And then I have my 3 points to plot. I can go to 1/3, 3, 1, 0, and 3, -3, like so. And I can just draw that in there, and there is my graph. My domain goes from 0 to infinity, and my range is all real numbers. Any questions about any of that? If you didn't have to graph it and you could sketch it, would that make this a whole lot easier? Could you have gotten that shape pretty much? Yes. By understanding that once you get here, this point isn't going to move. And since it's a vertical stretch, instead of it coming up quickly like this, it gets stretched out. Those are the things that you really need to understand. So past this, with us actually graphing some of these and getting some ordered pairs, the sketching is really what's more important to us, understanding what's happening with the shape. Right now, the sketching should help you know if what you have right here makes sense or not. Okay, we good? Any questions?